In this video, we'll be taking a look at the problem Postal Vans. So here we have a few avenues, and we always have 4 horizontal rows, but we're given an amount of streets that are running north-south, so a few columns, and we're asked to find the total number of moves for us to start at this first point and then go through all of the intersections without going through them twice or more, and somehow end up at the first point again. So here the counting part is actually really easy. The most complicated part is implementing the big numbers because this n can be quite big and we won't be able to store it using normal integers. So first of all, let's take a look at how we can calculate the total number of moves. So here, instead of thinking of our starting point as here, we can think of it as ending here because they will be the same thing. And this way we will be able to loop from 1 to n, and this way it will be easier for the loop to go. And so here, whenever we're at a certain point, for example here, there are always a few ways for us to get to this point. And one way is when we are looking at when we are approaching this point. So this will be the two endings. One is let's say going from this direction. So we're basically having one arrow. We're starting here, and then we somehow go through everything else, and then ends up here. Or we don't need to exactly end up at this place. We can start here still, and we just have to end up here. As long as we end up here, we can go and visit this point again. So we'll be able to loop through everything. So here we're basically asked to find the total number of moves that can help us reach this point, which is one point beneath our this point. So we're asked to find this total amount of moves, and there are a few ways we can reach this point. The first way we can reach this point is like what I said here. We can maybe move around and then somehow end up here at this point, and then we go to this point. And then there's another way where we could end up, we could be at this point, and then we go here, and then go here, like this. And it is not possible to go to be at this point here, because then if you're doing this, you have to go up, and then this. But this way you will have to skip either. So you have to skip this point definitely, because you can go here and then go here, but you will miss this intersection. So this is definitely not possible. But you can do this. So you will be able to visit this point and then go back up to this point that we're looking for. So then this way we can connect back to this point, this starting point. But this point, this path is basically the same thing as our point being here, because it's just moving here and then moving up again to this point. So these are basically the same possibilities. We just have to count the total amount of moves for us to start at this point and then go here, and the total amount of moves for us to start at this point and then go here, like so. And so, of course, here we need to find a few things. The first one will be the total amount of moves we can reach this point and this point, because these two are needed for us to calculate the total amount of moves for us to reach these 2 points on the next level. So for the next column, we will need these 2 points, because as I said, we have to get this possible amount of moves, so then we can move this way. And then we'll just add whatever this total amount of move is to this our next column for this 2 dots at the beginning. So we have to find these separate dots, and we need this as well, because this way we can go directly to here. So then for this part, the total number of moves for us to get to this point will be the total number of moves for this. So basically, now we're looking at this final column. We can basically think of this as one column after the first column as well. This will apply for each of these columns. So first of all, there's definitely a possible way for if our first previous points were here at this row, so at this column, I mean, because then we can just go here, or we can let's say go here, and then travel around all of the other intersections, and then end up here at this point. So then we can go to this point, and then go up to this point, which will complete our cycle. So this is one possible way. So and the total amount of moves to get to this is just the same way, calculated the same way as what we're calculating right now. And so let's call these we can call these types of moves and give them an array A, let's say. And then also we're looking for another type of moves where we're finding these two, because then when we're looking at these 2 points, we can move here, and then here, and then here, right? So we will still end up at this point. So this total amount of moves, let's also call a name and just name it B. Okay, so first of all, we can see how we can find all of those. Then this A, let's say we are currently at column I, so this will be I minus 1. And then here we already found, we already have A I minus 1, and also we have B I minus 1 as well. So because we're calculating from column by column, so we'll have the previous one already. And then the total amount of moves for this position, which is what we call AI. And remember, AI is the number of moves for us to reach 2 points like this, and BI is amount of moves for us to reach 2 points with the first point on the top and the next point, the second point on the bottom row. So first of all, this will be our AI because we're looking at these two numbers or these 2 points. So this will be equal to the AI minus 1 plus the BI minus 1, because that's what we found. We found we can go to this point using these 2 points, and we can also go to these 2 points using these 2 points. So then here we found AI, so this will give us how to calculate AI, and we need to find how to calculate BI for each of these. And so let's take a look at a few ways that we can calculate BI. First of all, we can let's just draw this out here. These will be the points that we want to reach, and we'll have a few previous points. So we have these points from the previous values. We can see how we can calculate these 2 points. And so first of all, there's this way we can we can use this point and this point. So first this point will go here, and this point can go here. So this will be one way, and then there's also another way, basically the reverse of these 2 points. We select these 2 points instead, and for one of them we go this way, and for the other one we go this way. So here we're reaching these 2 points still as normal. And so these 2 ways are basically the same thing but flipped over. And so we need to find the total amount of moves we can get to reach these 2 points. So basically we want to get the 2 times of this. And this, as you notice, is just the same as this. Exactly the top 2 points, and we want to find the total amount of moves for that. So for each BI, it's definitely gonna be 2 of the previous AI minus 1, because we're looking at the previous row. Let's just we can think of this row as I minus 1, this row as I. Okay, so definitely 2 ways for us to reach this point using 2 previous points like so. One is at the top and one is at the bottom. And then we also have another way, which is this way. And we can also reach these 2 points this way. but of course here we have to reach these 2 points, and to do that we must visit these points, because if we don't visit these points, we just go straight here, then we're going to visit this point and we cannot visit this point anymore, because if we go back here we will not be able to find a way to pass this line that we just made, and then we cannot advance to the next column. So we definitely need to visit these 2 points, and to do that, this means that we definitely have to do this, going forward like this. And here we're basically looking at this same thing again. This way we have to move this here and then go here, and the other one is go here and then go here. So to get this, we basically need the total number of moves we can get for these columns, because this is basically moving forward once and then doing this exactly the same thing. You cannot have any changes in these few paths. So in this 4 edges or paths, you cannot change a direction or something. So this will be the only way, and we're basically wanting to find the total number of possible moves for these 2 points. And these 2 points, we're just looking at I minus 2. And so I minus 2, we're looking at column I minus 2, and the total number of ways for us to get that is just bi minus 2, because this is basically 1 point on the top row and 1 point on the bottom row, and this is exactly what we're finding here, 1 point on the top and 1 point on the bottom. So we also need to add a bi minus 2. This is the total number of moves that we can get to these 2 points. Alright, so now let's look at more ways for us to find the total number of moves for us to reach these 2 points at the top and bottom row of column I. So here there's definitely another simple way here. It's just starting at these 2 previous points on the same row but just 1 column before, and we can just move this way. So then this way we can also reach these 2 points. But here there are a few special cases. So here, if we visit these 2 this way, then these points here must be visited somehow. So there will definitely be a path that connects it this way, because this way we will be able to go through all of the intersections. So here, let's say we can start here and then go here. Then we will use this path exactly like how we said it must exist. So then it will start here again and then end up at this final point. So then this will, so of course here we have the normal way, that is just the total number of moves from before for the column I minus 1, because it's also the top and bottom row, it's just bi minus 1. But here there are a few special cases. Let's say there might be something where you have something like this, or it can be anything like just these previous connected ones, but they're blocked off. So they basically blocked off the path for us to reach the final point, because we want to be at this point, and then as what we did, we wanted to reach this point, the point at the second row. But here we cannot go visit the second row, because we already passed through these 2 points using this path. So we cannot go to the top. So these few cases will be special as well, but they also exist. So we should also account these into the total number of ways to reach the bottom and top, the top and bottom 2 points for column I. So like what I said, we could have something like this, and then somehow end up like this. So this is the case that we said might have existed. And this way we can think of this side as being blocked off, basically. So one of the sides is basically blocked off, and that way is just the top. We're basically seeing how many ways are there to visit these 2 top things, because if we visit these 2 top points, then this way we will definitely find the total number of moves to reach this point as well, because we want to go through this path. So we have to find the total number of points that can visit these two. So you can think of it as one of the points being like this, and the other point is opened, and something else here is there's some other paths here, and we don't have to mind about those other paths because we're just looking at these points. So here, the total number of ways for us to reach the last 2 points is basically the total number of ways for us to reach these 2 points, because everything else depends on the total number of moves for these 2 points. Since our path is not changing here, we're basically just moving this way. And the total number of points for us to reach these points is just I minus 2, because here this is the i's column, this will be the I minus 1's column, and this will be the I minus 2 column. So here this because this is basically the same thing as the 2 points being up here, so we can also have 2 points being up here connected like this, and then this side blocked off instead. So we should get 2 times of these 2 as well. So this is what we found at first. We have definitely these few values added up to our BI, and also we also need to add the 2 times I minus 2. So these points will keep track of the total number of moves for us to reach these. But also we also have to add the total number of moves for us to reach these 2 points, like for the normal case. Because there's also another way, and that is if this side is not connected. So we can basically ignore this edge here, and we see what this path will look like. So it will basically look like this way, because we don't have a path here. We're going all the way there, and then back, and then there again. So this is also possible. And so here the total number of possible ways. Let's just erase all of these useless ones. These are the useless points that we don't need. Okay, so here first of all we will go all the way there, or we can just say somewhere like there, but we can just go on like that, and then we come back here, exits there, and then goes here again. So then here, this way, we are not blocking this off. So if we don't block this off, this means we are not limited to using these 2 points. We can basically see the total number of moves for us to use these 2 previous points as well. And because this way, the total number of moves for us to reach the previous point is just moving this way as well. And then we can basically move there. We can ignore whatever is in the middle, just moving there normally. And then this way, it's basically just the same as our current calculation, because this middle part is still the same. It's still the same thing. So we should also keep track of the total number of previous moves for these 2 points that are also like having these special cases, because we're accounting the special cases only. We shouldn't account these cases that won't contain any of these complicated cycles or anything. So this way we should let's just keep track of another value c, and then every time we should ci is basically equal to the total number of moves, because here we're basically looking at the special moves for these 2 points, and the total number of special moves for this current point is the total number of special moves for the previous point, plus the the few cases that I said in the beginning here. So if one of the sides are like this way, so we're going through here, and then so basically like this way, then we shouldn't look at these 2 points. We should also look at the previous 2 points that are beside each other, or on basically on the second and third row, or on the first and second row, or on the third and fourth row. So there are 2 ways to get that. One is on the top part and one is on the bottom part, and that's just 2a I minus 2. We're doing I minus 2 here because we're looking at one column even before the I minus 1 column. because here we are seeing what determines these two values, because these two values will help us determine the path for this current I, since we're traveling this complicated way. And then this way we will be able to get a C. And so here we don't need to use these anymore. We can just replace that with CI, because that's basically what we're looking for the current value. So now that we have all the equations calculated, we will be able to just program this out according to what we wrote. So here there are a few base cases that we must need, because we need the I minus 1 and I minus, so basically you need I minus 1 and I minus 2. So here we should first writing the base cases for when I is equal to 1 and when I is equal to 2. So here this is what I wrote. We know that for when I is equal to 1, there will be definitely no ways for us to reach, for us to complete the cycle, because let's just say we have this just one street. We have to start here, and then we will visit this point, and go here. So now we've already visited all the points, but we still need to go back. But there are no paths for us to go back anymore, because we visited all the points and we cannot revisit them. So now we're stuck, and so A1 is definitely equal to 0. And then here we can also calculate the total number of moves for A2. So this is when there are two streets, and there are only two ways. One way is going this way in this direction, forming this rectangular circle, and the other way is going this direction, forming this cycle. You cannot travel in any other ways, because then you will block the wave to go back to the beginning. So here A2 is definitely two ways, exactly what I said here. One cycle going this way and another cycle going the other way. So here we have both A1 and A2. Now we need to find B1 and B2. So to get B1, it's very simple. We already have A2, and we know that I is equal to AI minus 1 plus BI minus 1. So A2 would be equal to basically A1 plus B1. And since we already have A1, which is equal to 0, and A2 is equal to 2, then that just means that B1 will definitely equal to 2 as well, because 0 plus 2 is equal to 2. So here B1 is equal to 2. So now we have calculated the values for A1, A2, and B1. We just need to find the value for B2, because this way we can find all the base cases. That way we can build up according to those numbers. And to find B2, we can we can basically look at the example. Here when n is equal to 3, so when I is equal to 3, we have 4 possible routes. So basically A3 is equal to 4. And so this will give us the answer for what B2 is, because as I cite here, the AI is equal to AI minus 1 plus BI minus 1. So A3 should be equal to A2 plus B2. And since we know what A2 is and we know what A3 is, because A3 is stated here in the example, it's 4. We have 4 is equal to 2 plus B2, because A2 is 2 as what we found when we drew this out. So B will definitely be equal to 2 as well, because this way, because 4 minus 2, so you get 2. And so this is our base cases. Also, I also found the value for C using the same way. Basically just finding what BI is, and since we have BI, we can find C, because we also know what A is, and because so we can basically get what C is for when I is equal to 2, and it's equal to 2 because our B2 is equal to 2, and AI minus 1, which is 2 minus 1, is A1, and that is 0, so 2 times 0 is 0, and bi minus 2 is also 0 because 2 minus 2 is 0 and that doesn't exist. So the only value that we have left is C2. And since B2 is equal to 2, then C2 must be equal to 2 since everything else here is equal to 0. So our C is equal to 2 as well now. Now we can loop through all of the values starting at 3 and then to n because we already found the values for 1 and 2. And then we find, first of all, we find what C is according to our equation. And we already have it here. So basically adding on to the previous, we basically added to the previous C value and add to ai minus 2. So I added ai minus 2 twice here. I didn't use multiply because this way I just need a plus function for our big number operator. And then we can find ai. ai as stated here is ai minus 1 plus bi minus 1. This is exactly what we found here in this. And then b will also be found, will also be calculated the same way as stated here. We first of all add 2 of the ai minus 1. So this is 2 ai minus 1, and then add bi minus 2, and then plus our c value. And c value is the special cases for when we're looking at 2 points that ends here and here. And so finally, we just have to print out an, because an is the total number of moves for us to reach the nth column at these 2 points. So then we can connect those, and then we'll complete the cycle. So here, all we need to do left is implement the big number structure. So I created this array to keep track of all the digits. I set the maximum to 1000, and I think that is enough for this problem. It won't overflow. Then also use another variable to keep track of the length of this. So when we're initializing, I'll first set everything to 0, but if we have a number here, I'll just set the 0th digit or the first digit at basically at the ones place to equal to x, because I'm sure that when initializing, our x will definitely be smaller than 10, so we won't have any weird situations here. And then we just need a plus operator for our big number structure. We can add it, we can plus another big number to it. And to get the sum of those two, I will create another big number, and so that will be the sum of the two big numbers that we have. So first of all, this length of the C will be the maximum of these two numbers that we're adding. And then I will loop through all of the lengths and add the digits for both of the numbers at that position. And also here I will use a boolean to keep track of whether we're carrying one digit, we're carrying a 10 to the next place. So here we'll get a temporary sum for these. And if it's greater than or equal to 10, this means we should carry the 1 to the next digit, because this should only be a 1 digit, not 2 digits. So our carry will become true. So next time we can add 1 to our next value, which is also added here. Then we will minus t by 10. So this way we can get the only 1 digit. And otherwise, if it's smaller than 10, we don't need to carry anything, so we'll set it to 0. Then the digit at our current I position would just be equal to the sum. And here we already took away the 10, just in case it's greater than or equal to 10. And then finally, we'll take a look if we are still carrying 1 digit, because we can have we can add up to an extra number. For example, we can add 5 and 5. Here, the max length for both are equal to 1, because just 5 itself is just 1 digit. But at the end, we will end up carrying 1 digit, so we should increase our length by 1 again and set the final value to 1, because we're carrying 1 more digit to the next value, or to the next place. Then we can return our new big number, which is the sum of these two. And also here, I also created a print operator, so this way when we print out things, it will just print out in the reverse order, because we're starting at the ones place, and when we are writing numbers, we always put the ones place at the end. So I should start with the length of this digits that we have. So print the largest digit first, and then go down all the way to the ones place. So I print out everything, and this is what I basically used here. This way I can print out the big number without writing any extra functions or anything. So here I also have to create these create these variables outside. So these arrays, and here you don't. Although we wrote c as equal to c I minus 1 and stuff, we don't need to keep track. We only use c for this I minus 1, so we don't need to use an array for this. We can just add increase our c by this 2a I minus 2, because we can think of this current c as c I minus 1. And if we increase it by 2a I minus 2, it will just become ci. And so this is why I only use the c without adding any array. And here, these two should have the total maximum length of our n, which is the total maximum column number.